Alright guys, it's Mr. Martin here with our video on so when we talk about reflections, we're talking about reflecting geometric figures over either horizontal or vertical lines. So I want you guys to grab your notes and we'll get started. So first we're going to plot a triangle. So we're going to put a coordinate right here, we're going to put a coordinate right here, and we'll put a coordinate right here. And so we'll say that's A, B, and C. And so we want to reflect this image over the y-axis, this axis. To do that, what we want to do is count the coordinate, how far each we want to count how far each coordinate is from the y-axis. So if we look at A, we have 1, 2, 3, 4. So we want to move 4 in the right direction. 1, 2, 3, 4. We plot that coordinate. We'll call that A prime. When we look at coordinate B, it's 1 away, 1. So we want to move 1 in this direction. We'll call that coordinate B prime. And then when we look at coordinate C, it is 1, 2, 3, 4, 5, 6, 7 away. So we want to move 1, 2, 3, 4, 5, 6, 7. We'll call it coordinate C prime. We'll connect that. And so you can see that we reflected this image over the y-axis. So the coordinate for A is 1, 2, 3, 4, 1, 2, 3, 4, 5. So that coordinate is -4, +5. When we look at A prime, this coordinate is 1, 2, 3, 4, 1, 2, 3, 4, 5. It is +4, +5. We look at coordinate B, its coordinate is -1, +1. We look at coordinate B prime, its coordinate is +1, +1. We look at coordinate C, its coordinate is 1, 2, 3, 4, 5, 6, 7, -7, +2. And when we look at coordinate C prime, its coordinate is +7, +2. So what I want you guys to do on your notes is make a rule for what happens when we flip a geometric figure over the y-axis. In particular, pay attention to what happens to the x coordinates of each vertex. Now, if you guys have a rule, try to do number 2 on your own on the notes. Okay, so now we want to talk about maybe flipping a figure over the x-axis. So we're going to take like a rectangle. We have a coordinate here, a coordinate right here, a coordinate here, and a coordinate here. So we'll connect those. And we'll say that's A, B, C, and D. So we want to flip this over the x-axis. So we want to do the same thing where we count how far each coordinate is above the x-axis. So that will be, for A, it is 1, 2 above the x-axis. So we want to go 1, 2 below the x-axis. So we'll plot this point. We'll call it A prime. The same thing for B, is 2 above. So we go 2 below. We'll call that coordinate B prime. For C, C is 1, 2, 3, 4, 5, 6 above. So we want to go 6 below. 1, 2, 3, 4, 5, 6. And we'll call that coordinate C prime. And something similar for D prime. And we connect those with a line as well. Take this A prime out for a moment. We'll put it right here. And so again, we go through and we compare coordinates. For A, its coordinate is -2, +2. For A prime, its coordinate is -2, -2. For B, its coordinate is 4, 2. For B prime is 4, -2. For C, C is over 4 up 6, I believe. It was 4, 6. For C prime is 4, 1, 2, 3, 4, 5, 6, -6. And for D, it is -2, +6. And for D prime, -2, -6. So I want you guys to see what's the rule for when we flip everything over the x-axis. In this case, I want you to pay attention to the y-coordinates for each vertex and its reflected vertex. So after you guys come over the rule, pause the video, try to complete number 3 and 4, and then we'll move ahead to 5 and 6 on the notes. Okay, so next we want to say maybe we want to flip an image over a horizontal line that's not the x-axis. So like maybe that line. And we'll say is a triangle like right here. So if we label this A, B, and C, what we see is that so what we want to do still is count the distance for each vertex from the axis of reflection and go in the opposite direction and plot our new vertex. So for A is 1, 2, 3, 4, 5, 6 above this horizontal line of reflection. So we want to move 6 below that. 1, 2, 3, 4, 5, 6. And this is where A would go. So we want to call that coordinate A prime. For B, B is 2 above the axis of reflection. So we want to move 2 down. So we go 1, 2. And this is where the new B prime is. And for C, C is 1, 2, 3 above. So we want to go 3 below. 1, 2, 3. That gives us our new C prime. So if we connect those, again, let me take this A prime out. We see that this is our line of symmetry. Now again, notice that when we reflect over a horizontal line, the x coordinates do not change and the y coordinates do change. So what I want you guys to do is pause for a moment, see if you can come up with a rule for what happens when we reflect over a horizontal line, and then we'll see what happens when we reflect over any vertical line. So now say we have this vertical line right here, and we want to reflect this, we'll say rhombus. It's not exactly a rhombus, some quadrilateral. So we'll call this coordinate A, B, C, and D. So for this, we want to reflect in this direction. So in this case, A is 1, 2, 3, 4 away from the line. So we want to move 1, 2, 3, 4 in this direction. That gives us A prime. For B, B is 1, 2, 3, 4, 5, 6, 7, 8. So we want to move 1, 2, 3, 4, 5, 6, 7, 8. And that gives us B prime. D is 1, 2. So we want to move 1, 2 in this direction. Call that D prime. And C is 1, 2, 3, 4, 5, 6, 7. So we want to move 1, 2, 3, 4, 5, 6, 7. And so now we have our reflected image. Again, note the symmetry for this figure. The distance between the A's is the same. The distance between the D's is the same on both sides. For the C's, it is the same. And for B, they're both the same distance from this line of reflection. So what I want you guys to do is determine the rule for when we reflect an image over any vertical line. And after you guys do that, pause the video, try to complete number 6, and then we'll do number 7 and 8. All right, so last is if we want to reflect a line over, reflect an image over the line y equals x. So for the line y equals x, each x and y coordinate are the same. Like this coordinate is 1, 1. This coordinate is 2, 2. This coordinate is 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, and so forth. We connect with a line, and we'll go in the other direction as well. So we want to reflect the image across this line. So say we have a triangle where we have those 3 vertex points. So we have A, B, and C. What we want to do in this case is count how far it is from this point to the line, both up and to the right, or down and to the right. So if we look at A is 1, 2, 3, 4, 5, 6, 7, 8, 9 from that line in this direction. And it's also 1, 2, 3, 4, 5, 6, 7, 8, 9 in that direction. What we want to do is move in that same direction from where we touched that line. So we'll move down 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we could have done 1, 2, 3, 4, 5, 6, 7, 8, 9. You see how we created a box for where we want this other coordinate to go, and we want A to go in the opposite corner. So we have A prime right here. And we could do a similar thing for B, where B is 1, 2, 3, 4, and we go down 1, 2, 3, 4, recreated a spot where B goes. So we'll call that coordinate B prime. And for C, we could do the same, where we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and we get C prime. So what I'm going to do is take out all these random dots and we connect these, and we reflected that image over the line y equals x. Now again, note the symmetry. So B, if we did the distance formula between any point on this line and B, we see that this distance from here to here is the same as the distance from here to here. So what we want to do is like maybe note the coordinates. For A, its coordinate is -4, +5. For A prime, its coordinate is +5, -4. For B, its coordinate is -3, +1. And for B prime is 1, -3. And for C prime is 1, 2, 3, 4, 5, 6, 7 is -7, +2. And so for C prime, we're going to get 2, -7. Can you determine a rule for what happens when we flip over the line y equals x? What happens to these coordinates to get these coordinates? All right, so go back and see if you can figure out what happened. And after you do that, please complete number 7 and number 8. And I thank you guys for watching. I'll see you in class.